we're going to go over Leetcode, check completeness of a binary tree question. Major tech companies like Microsoft, Google, Facebook are asking this question while they're conducting their technical interview. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given a binary tree, determine if it's a complete binary tree. Definition of a complete binary tree from Wikipedia. In a complete binary tree, every level, except possibly the last, is completely filled, and all nodes in the last level are as far left as possible. It can have between 1 and 2 nodes inclusive at the last level H. So, according to this definition, all the levels should be filled, first level, second level, except possibly the last. The last one can be filled or not. And all the nodes in the last level are as far left as possible. So they should be all shifted to the left. They should be all as far left as possible. For example, this is a complete binary tree. All the items are as far left as possible. But this is not a complete binary tree because 7 is not as far left as possible. It should be on the left. And last one can be null. So how are we going to solve this problem? We are going to use breadth first search algorithm to solve this question, and using level ordered traversal, and we will go from left towards right. We will do each level using BFS. And in the last level, when we go from left to right, if we hit any null, and if there is any value after null, that means that's not a complete binary tree. Null value should be only on the very last node. We can't have a null node before the value. For example, in this case, null comes before the value, so we can't. So this is another complete binary tree. Null has to be in the end, and there can be a value before null. So let's see this in the code as well. First, we add root to the queue. Let's do that. Yes. So queue is not empty. Then we poll the current root node, and we add left and right nodes. In this case, 2 and 3. And this one is polled. In the queue, we check if the current item is null, then we say end is true. Because we can't have a null we can't have a null and a value coming after. Null has to be the end value. So as soon as we see null, that means we hit the end. If there is any value coming after the end, that means we are returning, because this null has to be in the very end. I hope it makes sense. So we poll 2 now. Let's poll 2. And we add left and right values 4 and 5. So 4 goes here, 5 goes here. Then we poll 3. I'm following the code, by the way. Every time I pull an item from the queue, and that's the item I pull, and this time it will be 6. And we need to be careful, we're going from left to right, and the last one is null. If you notice, we are adding first left then right. So this way, if you look at it, end value comes after, then no value comes. So we hit the null value, then no value comes after. So this is a complete binary tree. But in this case, null will be somewhere here, and 7 comes after. In this case, null will be before 7, and this is not a complete binary tree. So this end will return false, if that makes sense. Let's see it in the code. First we define end, which is false, and define a queue, it's a linked list, and add the root item to the queue. Then start pulling from the queue and adding left and right nodes and checking if it's end or not. If it's end, we're returning false. Otherwise we return true. So this is where we check if it's breaking or not. And this is where we set, if as soon as we hit a null, we return it, we make it true. If it's if it's end is true, then we return from here. Let's submit and see. Okay, this worked. I hope this made sense to you guys. I have more videos coming up, so if you subscribe to my channel, we can meet again later. Thanks for watching. Goodbye.